Hello there and welcome to a brand new lesson. This is Hab Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at composite functions. And by the end of this lesson, you should be able to define composite functions and explain the meaning of f of g of x and then g of f of x. You should be able to evaluate composite functions for specific numeric inputs. You should be able to find the algebraic expressions for f of g of x and then g of f of x and simplify. You should be able to demonstrate that f of g of x is not equal to g of f of x. In general, the order really matters. And finally, you should be able to solve equations of the form f of g of x equals k and find unknowns in composite functions. Over here are some vocabularies we'll be using along the way. I would advise that you pause and then quickly glance through them before we start the lesson. Without much ado, let's quickly look into it. So let's start by first of all looking at what a composite function is. When we talk of a composite function, then we simply mean you are applying one function to the output of another. You see, so most of the times this is how we write it. So let's say you have two functions. You have f of x and you also have g of x. You see, then if you have f of g of x, this here, it simply means evaluate the g of x. The answer you get for the g of x, come and put that value as what? X, and then you find the f of x. You see, so this here can also be written as what? F of g of x. These are the basic or standard notations that we need to understand. Okay, so how does this even work? So just as I said, you have g of x and then you have f of x. The first thing you need to do is to what? Get your x value. If you get your x value, then you apply it first to the function inside, or let me say to the right hand side function. Okay, the answer you get, you now come and put it into the next function, and that will give you the results. Now you would have to take note that the order really does matter. So that is to say that if you want f of g, it is not the same as g of f. Let me give you a simple example. As we proceed, we'll solve 5 more examples to enhance our understanding. But for this basic one here, let's say f of x is equal to x plus 2. And then g of x, on the other hand, is equal to 3x. Then if you want, let's say, f of g of x, then what is it going to be? It simply means anywhere we see the x value, we are going to put the whole of g of x over there. So we can rewrite it as f of g of x. You see, so with that, it is going to give us x. And we are saying the x now is all of the g of x. So 3x, then plus 2. This is f of g of x. But if you want g of f of x, then it simply means that we have our function g and we are substituting its x value with f of x. That, on the other hand, is going to give us 3. Then whoever will see the x, we are going to put all of this over there, which is x plus 2. Evaluating, we are going to get a 3x plus 6. Now, looking at these two answers, you can clearly see that they are not the same. Hence, the order really matters. This is how we solve composite functions, but let me give you the step-by-step method. So here are the step-by-step procedure we use to find composite functions algebraically. You first of all need to identify the inner function. So most of the time, the inner function is the one to your right. the rightmost function is your inner function. Then you evaluate it. So you evaluate it with the value of x you have been given. After which you now substitute the inner function's expression wherever x appears in the outer fraction. So whatever you've gotten for the inner function, you now come and put it in here for the outer function. You expand and simplify fully, and then you can choose to verify by testing specific values numerically. Here are the steps. So with these, let's solve some questions to enhance our understanding. Our first question here says f of x equals 2x plus 1, and then g of x is x minus 3. So you have to find f of g of 5 and then g of f of 5. How do we evaluate this? There are two ways we can do it. So first of all, we know our f of x is equal to 2x plus 1. And we also know our g of x is equal to an x minus 3. So for f g of 5, what we are going to do is we first of all need our g of 5. You see? So for our g of 5, it simply means we are substituting x for 5. Anywhere we see x, we are going to put 5 over there. So instead of this x, we are putting what? 5 minus 3. And 5 minus 3 gives us what? A 2. So g of 5 has given us a 2. It simply means our f of g of 5. We know this is actually f of what? The function g of 5. You see? So this is going to be f of g of 5 here gave us 2. So we are just coming to put the 2 there. So that it simply means we are now looking for f of 2. You see? So our f of 2 is going to be what? We know the function of f of x. And all we are saying now is we should substitute x for 2. So we have 2 of 2 plus 1. This one evaluated gives us a 4 plus 1, which is a 5. As simple as that. For the second one as well, we want a g of f of 5. So let's first solve f of 5. So f of 5 is then going to be anywhere we see x in f of x function, we are going to put 5 there. So that we have 2 into bracket the 5 plus 1. 2 times 5 then gives us a 10. So we have 10 plus 1. So it simply means our f of 5 gives us an 11. So with that, we now want our g of f of 5, which we know it's simply g of into bracket f of 5. So it implies we have g of the f of 5 gave us 11. So we want g of 11. Solving for g of 11, we have the formula here, which is x minus 3. So g of 11 is then going to be equal to the x, which now is 11. So 11 minus 3, which is also an 8. So what have we done? It simply means f of g of 5 is what? 5. And g of f of 5 as well is what? 8. And you can see they are different. This is to tell you the essence of order. So as we evaluated g first over here and then substituted it into f, we see our answer. As we substituted f of 5 first into our g, we also saw our answer. So for our second question here, it says f of x equals 2x plus 1, and then g of x is x minus 3. We have to find expressions for f of g of x and then g of f of x. This time around, we've not been given any value. We want the general expressions for these. So for our a, that is f of g of x. So let me write it just as we see. So f of g of x. This simply means f, and then we have to put g of x inside. You see? Now we already know g of x to be, as given here, x minus 3. And we already know f of x as what? 2x plus 1. So this implies that if you want f of g of x, that is to say, wherever we see x, we should put the whole of g of x. Then it's going to be 2. Then instead of the x, we're going to put g of x. Meanwhile, g of x is all of this one. So into bracket x minus 3. Then plus 1. Then we do our necessary simplification. 2 times x and then 2 times negative 3. That gives us a 2x minus 6 and then plus a 1. This one simplified, we have a 2x then minus 5. This is the general expression for what? F of g of x. For the second one, we have g of f of x. And we know what that means. It simply means what? The whole of g. We are substituting f of x in there. And once again, we know what g of x is. We know what f of x is. So that is to say, our g of f of x is going to be, first of all, it says let's write all of x. And all of x now is f of x. So f of x, which is 2x plus 1. So 2x plus 1, that is in place of the x, then minus 3. So minus 3. Simplifying further, we have 2x, then minus 2. That is all. Now, if you want to verify using what we did over here, remember we had f of g of 5 giving us what? The answer 5. So testing it out, that is to say, if x is 5, we have 2 into bracket 5, then minus 5. 2 times 5 gives us a 10. 10 minus 5 gives us a 5. So at least that works for the first one. What of the second one? So that is to say, we have 2 into bracket 5, then minus 2. 2 into bracket 5 gives us a 10. 10 minus 2 also gives us an 8. You see, so if you're able to get the general expression, it is always simpler to just quickly substitute any number at all, and then you go your way. Let's look at our third question. Our third question here says, f of x gives us an x squared, and then g of x is a 3x plus 2. We have to find and simplify f of g of x. So we have f of x being x squared, and then g of x being a 3x plus 2. If you want f of g of x, then it simply means for the function f, to substitute g of x inside. Okay, so that simply implies that this here is my f of x. It says x squared. Whatever is inside in place of x should be squared. In this case, what is inside is what? G of x. So we are going to square 3x plus 2. You see, so squaring this, we have 3x squared, which gives us a 9x squared plus 2 times 3 is 6 plus 2, we have a 12x, and then plus 2 squared, which gives us a 4. This is our answer. I use the Pascal's triangle to do this evaluation. Now the second one says we want f of x. f of x. How are we going to do that? So this time around is saying we should find f when we substitute its own function in place of it. And we know what f of x is. So this is to say, instead of x squared, let's substitute f of x inside that again. So that is to say, x squared should be squared again. Now, squaring s squared using our laws of indices, we are going to get x raised to the power 2 times 2, which is x to the power 4. You see? So with this, we can say, therefore, first of all, our f of g of x gives us a 9x squared plus 12x and then plus 4. And then secondly, f of x, on the other hand, gives us an x to the power 4. And that is just it. Question number 4. And last but one question here. And I do want to believe that you are pausing and trying the questions before looking at the suggested solutions. If you did that for this as well, well done. Now let's solve it together. So our solution. We first of all have our function f of x being equal to 3x minus 1. And we have g of x as well, which is equal to an x plus 4. And we want to solve for f of g of x is equal to 20. So what this means is we should find the value of x that actually makes this 20. So the first thing we need to do is to evaluate or find a general expression for this. That is to say, f of g of x we know is equal to f of g of x. So anywhere we see the function of x, we'll substitute it with the function of g. So instead of 3 times x, this x now is going to be substituted with all of this. That is x plus 4. We have 3 into bracket x plus what? 4. So we are done with 3 times x, then minus 1. So minus 1. Simplifying this, we have our 3x plus 12 minus 1, which gives us a 3x plus 11. But we know that what? F of g of x is equal to 20. That is from what we've been given in here. Now this is to imply that this which we have solved as the general expression for f of g of x, that is 3x plus 11, is then equal to 20. So all we need to do is to make x the subject. Making x the subject, we have 3x, which is equal to a 20 minus 11. 20 minus 11 gives us a 9. We then divide both sides by what? 3. And dividing both sides by 3, we have our x, which is equal to 3. As simple as that. So we end up saying, therefore, x equals 3. And that is all. So it is when you put x to be 3 in this composite function that would result in what, or give an output of 20. As simple as that. Let's look at our last question for this session. Our last question here says f of x is given as what? 2x plus a. G of x is given as bx minus 3. But then if f of g of x is 6x minus 1, let's find the values of a and then b. So how do we go about this? First of all, we know f of x to be 2x plus a, and then g of x to be what? A bx minus 3. What has happened here is they have substituted already, and then this is the general expression for this composite function. But in here, we don't have numbers, we have letters. So we need to find that again and then equate it to this to help us get some equations involving variables and then solve for a and b. That means f of g of x is going to be, so we have our 2 into bracket x, and in this case our x is all of g of x, so into bracket bx minus 3, then we have a plus a. Simplifying this, we have 2bx then minus a 6, that is 2 times negative 3 plus an a. There is nothing else to simplify here, but we know that f of g of x is equal to 6x minus 1. So what we do is we compare what we have over here. Looking at what we solved, we had 2bx then minus 6 plus a. So what we have here, it is a 6x minus 1. If we are to compare, look at that which has the x and then that which does not have. That is to say that 2b and then 6 are in one column, and then we also have all of this as well in one column. So with that, we can then form an equation and say 2b is equal to 6. You see, so you see this implies that 2b is equal to 6, and making b the subject, our b is equal to what? 3. This, on the other hand, we can say it implies that a negative 6 plus a is equal to negative 1. So making our a the subject, we have a equals negative 1 and then plus 6, which means our a is equal to a 5. And that is all. So we can conclude by saying, therefore, our a is equal to 5, and then the b on the other hand is equal to 3. After this, you can confirm to find out if it is true. What do I mean by let's confirm? Our f of x now becomes 2x. Then instead of the a, we have what? Plus 5. Then for the g of x, it also becomes bx. Our b is 3. So 3x then minus 3. So what I mean by confirming is using these two functions. Let's find f of g of x ourselves to determine whether or not you are going to get what we have here. So that is an assignment to you, just to test your understanding. In view of that, we have come to the end of this lesson, and as usual, I'll leave you with some exercises so you try on your own. So here are just 5 exercises you can try on your own. They are very, very simple, and then they are just as what we did in here. I do hope this lesson was helpful. If there's any issue of concern, you can always let me know in the comment section. See you in our next lesson. And if this is your first time on this channel and you so do wish, you can choose to subscribe so that anytime I release a video, you'll be notified as well. Bye for now, and do stay safe.